This is 13A, box and whisker plots. And again, the notes in the practice are all in one in this packet. So once you're done with these notes, these are your last notes in practice for the year. Woohoo! And you can just continue with your final exam review. So box and whisker, I wanted to make sure you had been exposed to before some of those tests again. So here's our definitions. You're going to pause if I go too fast so that you can copy it down. So a box and whisker plot is a data display that organizes data values into 4 groups. That's kind of the key there. Quartiles are parts of that box and whisker plot. The median of the lower half is the first quartile. So you have split the data in half. The bottom half is the middle part is the first quartile. And the upper half, the middle of that upper half is the third quartile. The median happens to be the second quartile. The inner quartile range is the difference between the upper and the lower quartile. So it's the third quartile minus the first. And an outlier is a value that is widely separated from the rest of the data. So that all those definitions may seem pretty confusing right now. We're going to be talking through a box and whisker plot to help you understand these better as they apply to a problem. So here's our example to help us with that. We have a box and whisker plot of the heights in inches of 7 family members. So the first thing we need to do is we need to order the data. We need to put the data in numerical order. So the smallest number is 34. Then we have 46, 54, 62, 67, 70, 75. That's key. You got to get in numerical order first, okay? Then you divide the data into an upper and a lower half. Well, there's an odd number in our data set, so this is the very middle. It is the median. If there was an even number, we would split the difference of the two middles. We'd find the mean of the two middles. Now, this down here is the lower half. The median doesn't get included. If it's a number by itself, it doesn't get included in the upper or the lower. And then you find the middle of the lower half. It's 46. So that's called the lower quartile. And sometimes on standardized tests, it can be referred to as the first quartile. The middle of the upper half, here's my upper half. The middle of the upper half is the upper quartile. And that's 70 in this case. And that's also referred to as the third quartile. Remember, the median is sometimes called the second quartile. Okay, so then what you do is you identify 5 key numbers. The 5 key numbers consist of, oops, I wanted to get something a little bit different in color. Let's try that again. The lower quartile, the upper quartile, the median, and how do you get 2 more numbers? The low and the high. Those are my 5 key numbers that are going to be represented on my box and whisker plot. So my box and whisker plot doesn't go on the number line, it goes above or below. They left us room for below. All I'm going to do right now is in a linear way, I'm going to put dots, and it looks like, would they count by 2s? 32, 4, 6, 8. Yep, they counted by 2s. I'm going to put dots where these values are. So there's 34, 46, 62, 70, and 75, roughly right there, okay? Now, the whiskers are lines, that should have been with a ruler, good grief, lines going from the lower quartile to the smaller number and the upper quartile to the highest number. Then you make your box. There are lines actually at these 3 terms, and that's what a box and whisker plot looks like. So there's my median right there, and I'm just going to put those numbers in right now because this is a pretty small graph. So this was 34, 46, 62, 70, and 75. So what this is showing you is that the numbers up above were closer together. So to kind of step 3 was to draw our box from the lower quartile to the upper quartile, draw a vertical segment through the median. okay? And then draw the segments as the whiskers, kind of like cat whiskers. Okay, so on the next page, guess what? You get to do a box and whisker plot of the data. So walk through the steps. You're going to make your own number lines. You need to probably use a ruler this time because not one is drawn for you. Pause the video and go ahead. Okay, so here's my data in numerical order. This time there was an even number, so the middle number is the average of the two middle. Well, the average of 5 and 5 is 5, so my median is 5. Since there wasn't a number that I took out of the data set, these two numbers go with the bottom half and the upper half. So I have 5 in each. So there's my middle term, which is my lower quartile, my least value, my upper quartile, and my upper value. I used a number line, and I drew it first, and I drew my box and whisker plot above this time. There are my dots at each of the numbers, my whiskers, my box, my median. All right, be sure to check in with Mrs. Lyman if you're having any trouble with that. So now we want to know how to read a box and whisker plot. So we have an example here, and it has the average monthly high temperatures in degrees Fahrenheit in Atlanta, and it lists them all out. These data were used to create the box and whisker plot in example 2. Oops, I'm reading the wrong direction. Sorry, I'm on example 3. Good grief. All right, the box and whisker plots is still the same thing. It's the average high temperature for each month in Atlanta, Georgia, and Orlando, Florida. Just by glancing at that, you can tell automatically where it's warmer. Where is it warmer? Atlanta or Orlando? Or Atlanta or Orlando? Orlando. Definitely Orlando. So we have a couple questions they ask us though. For how many months is Atlanta's average high temperature less than 60 degrees? Okay? So what you have to decide is where am I talking about, first of all. So here's 60 degrees. This would be this area from here to here, which is less. So for Atlanta, the lower quartile is 60. That number was actually 60. A whisker represents, if it's a quartile, what does quartile mean? A quarter of the data. So what percent of the data is in there? 25%. Here's 25% of the data. Here's 25%, 25%, 25%. You've just cut them up into quarters like you did up above there. So a whisker represents 25% of the data. So for 25% of the year, well, how many months are in a year? 25% of 12 months. So how many months are a quarter of a year? 3 months. So for 3 months of the year, Atlanta's average high is less than 60 degrees. Not bad. Way different than Michigan, clearly. Okay, and then B says compare the average high temperature in Atlanta with the average high temperature in Orlando. So the median average high temperature for a month in Atlanta, what is it? There's your median. It's 73. The median average high temperature for a month in Orlando is 84. In general, the average high temperature is higher in Orlando. Now they give us some more data to look at. For Atlanta, the interquartile range, so that's the upper quartile minus the lower quartile. So that's 84.5, there's your upper quartile, minus 60 is 24.5. So you actually calculate the number, it's 24.5 degrees. In Orlando, the interquartile range is 90.5 minus 76.5. 90.5 minus 76.5. That difference is 14 degrees. So the range for Atlanta is greater than the range for Orlando. So Atlanta has more variation in average high temperatures per month. All right, so my next page here, flip it. In example 2, for how many months was the average high temperature in Orlando more than 84 degrees? In example 2, okay. How many months was Orlando more than 84? Right here and right here. So a quarter of the data is 3 months, a quarter of the data is 3 months. 3 plus 3 is what? 6 months. There you go. Oops. There you go. All right. So the last example is identifying an outlier. There's an actual mathematical formula for going through and calculating that. We're just going to kind of look at the information and say, is something kind of out of the rest of the information. So to do that, we have the average monthly high temperatures in degrees in Atlanta, and these are the average highs. These data were used to create the box and whisker plot in example 2. That's what I had been reading earlier. Find the outlier of the data set if possible. Sometimes there's an outlier, sometimes there's not. So it says from example 2, you know the interquartile range of the data is 24.5 degrees Fahrenheit. We just calculated that on the previous page. What you will do is you'll find 1.5 times that interquartile range. This is kind of the easy general calculation rule of thumb. It's 36.75. From example 2, you also know that the lower quartile is 60 and the upper quartile is 84.5. A value less than, so we're going to take 60 and we're going to subtract this number, 36.575 is 23.25. Okay? A value greater than our upper quartile, and then we add our upper quartile, which is 84.5, we add the 36.75 to it. If it's greater than 121.25, then we have an outlier. So it has to be less than this, greater than that. There are no values that are outliers, are there? There's no value less than 23.25, and there's no value greater than 121.25. So the data has no outlier, does not have an outlier. Okay? All right, so you're going to kind of do that same thing here, and you're going to go through and see if there's an outlier in that. So pause. You're going to have to order it, find your median, all that good stuff. You don't have to draw the box and whisker, but you do have to do the calculations. All right, so here we go. Here's my data set in order. The middle was right in between. It's 25.5. I don't need that information for right now. My lower quartile is 19.5. My upper quartile is 31. The difference between those two is 11.5, and you multiply it by 1.5. So that's 17.25. So then you take 17.25 and you subtract it from the lower, and it's 2.25. Well, I don't have a data point lower than that, so I'm okay on that end. On this end, it's 31. You add 17.25, and it's 48.25. Do I have something? 49 right there. It's outside of that, so 49 is the outlier. Okay, that's the end of your notes and practice for the year. Woohoo! Good job.